Hello. Today we're going to venture into module 12 and we're going to talk about risk treatment. And I'm going to share the screen with you. And the PowerPoint presentation. There we go. All right, here we go. Risk treatment involves the selection and application of risk reduction methods for a risk that is judged to be unacceptable. In other words, if it's acceptable, obviously you're not going to do anything about it. So it's the end result of the risk assessment process. The terms hazard or risk control, prevention, reduction, protection, and mitigation are all used to refer to risk treatment and are frequently used interchangeably by safety professionals. But let's look at each one a little bit closer. The term hazard or risk control, prevention, mitigation is the action of reducing the severity of seriousness of something. Mitigation is used to reduce risk, but it does not include prevention of an event. So mitigation is basically just reducing the risk. Doesn't prevent the event from happening. Risk protection is the act of protecting, shielding, covering, or keeping an asset from harm. An example is an automatic fire suppression system in a building. Insurance, a form of risk transfer, is also considered a protection measure. Risk prevention is the act of keeping something that would cause risk from occurring. An example is a pressure relief valve on an enclosed tank to prevent overpressurization and potential explosion. Risk control is a more encompassing term, meaning to manage risk by reducing the likelihood and severity of an exposure. Risk reduction, like risk control, seeks to reduce the likelihood and severity of an unwanted risk. All these terms address elements of risk treatment, and often a combination of them are used. Recognized and generally accepted good engineering practices. I know you've heard this before, and it's commonly called RAGA-GEP. It was introduced by OSHA in CFR 29.19.10.119, Process Safety Management, or PSM standard. The PSM standard requires that all equipment in PSM covered processes comply with what it states. It allows employers to select the RAGA-GEP they apply in their covered processes. When the design code standards or practices used in the design and construction of existing equipment are no longer in general use, the employer must determine and document that the equipment is designed, maintained, inspected, tested, and operating in a safe manner. So this is OSHA's stopgap. If something is old and you don't have data on it, or the manufacturer may be out of business even, that doesn't leave you off the hook. You have to make sure that the equipment is designed, maintained, inspected, tested, and operating in a safe manner. Now, one risk treatment is called safer technology and alternatives. This is kind of like another version of hazard, the kind of hierarchy of controls. We'll look at it a little bit and you'll see the resemblance. Safer technology and alternative is a risk reduction approach for chemical incident prevention. It relies on a hierarchy of controls very similar to the one commonly used in this course, but defines the hierarchy steps as follows. Number one, avoid hazard. The first order inherent safety measures, measures that would avoid or eliminate the hazard altogether. All right, that's pretty obvious and it's pretty common to almost all of these hierarchies of control. Reduce severity, second order inherent safety measures, measures that treat the hazard by reducing the hazard's intensity or severity. Not too much different from the second one done, right, in our hierarchy of controls. Reduce likelihood, second order inherent safety measures, measures that reduce the likelihood of the event or exposure. Passive safeguards, layers of protection, measures that reduce the frequency or impact of the hazard without the need for external input or activation or control. Examples include fixed guards, barriers, dikes, containment buildings. So this is passive. This is like what in hierarchy of controls. So then like engineering controls, right? Active safeguards. Okay, get what they're called passive safeguards. In other words, they're there. You don't have to do anything. They're just always there. And they're called a layer of protection. And that makes a lot of sense. Active safeguards, layers of protection again, measures that detect and respond to process deviations that require external input and activation of the control to provide safety. Procedural safeguards, this again, layers of protection, Measures such as operating procedures, management systems, procedures, and administrative measures that rely on the human element to respond or perform. We would call these administrative controls. So you can see there's a lot of similarity there. And this is called safer technology and alternatives. Now, identifying risk treatment options. The risk assessment team or decision makers must determine the options available and their degree of risk reduction, the reliability, and the cost of implementing them and maintaining them. They should consider both internal and external sources. Some internal sources would be occupational health and safety professionals. They'd probably be at the top of your list. Experienced stakeholders, in other words, stakeholders that have experience in whatever the operation or you're doing. Operators familiar with the hazard and how the control measures would impact them. Affected workers knowledgeable in the operation, equipment, or process. Never, ever lose sight of the fact that your operators and workers are stakeholders in this, and they should be consulted. External sources, manufacturers' literature, such as operating and maintenance manuals. Very important. Manufacturer's agent or representative, industry best practices, industry consensus standards. Let's go over these a little bit. Manufacturer's literature. As you know, process safety management, they will use manufacturer's literature. If you're not following it, they will cite you on that. You have to follow the manufacturer's literature. And I'm sure there's an out there if you can prove something you're doing is more effective, but chances are, if it gets to that point, there's already been something wrong. Manufacturer's agent or representatives. Now, sometimes the manufacturer's agents are just salespeople and they really don't know much about the product. But a lot of times, the more technical you get, the better the agent or representative can be, and they can be very helpful to you. Industry best practices. Within your industry, there are usually some groups of safety, some safety council, whatever, and they can help you a lot too. And industry consensus standards. Again, ask people in your own industry if they have some standards that they use. It's just a consensus. In other words, it's not a formal standard. It's just what everybody kind of agreed to do. NIOSH publications, you know what that is, National Institute of Occupational Safety and Health. There's a lot of them out there. OSHA regulations. We all know a lot about OSHA regulations. They're very helpful. Benchmarking other organizations with similar equipment or processes. Benchmarking means comparing what you're doing to what somebody else is doing. And that's often really, organizations like to do that because they want to see how they stand with other people, obviously. And subject matter experts, consultants. Don't ever hesitate to bring in a consultant if you need it. Hierarchy of risk reduction strategies. Risk treatment selection should always be linked to the concept of the hierarchy of controls to reduce risk to an acceptable level. There are many permutations of this concept, but they frequently share similarities, such as having the most effective and reliable options at the top, descending to the lowest level, which is usually PPE. The multicolored triangle with the descending categories of elimination, substitution, engineering controls, administrative controls, and PPE is very common. It's called NIOSH's Prevention Through Design, PTD hierarchy of controls. And that's the one that we're going to use in this course. I think it's about the simplest one and explains elimination, physically remove the hazard, substitution, replace the hazard with something less toxic or less dangerous, engineering controls, isolate people from the hazard, administrative controls, change the way people work, and the last and the least effective, PPE, protect the worker with personal protective equipment. You can see the bar on the left says the most effective down to the least effective. Now, this is the ANSI Z10 hierarchy of controls. It's very similar, but we'll talk about it for a minute here. Elimination, designed to eliminate hazards such as falls, hazardous materials, confined spaces, manual materials handling, that type of thing. You can eliminate confined spaces or places where you can fall. If you can do that, that's the best way to do it, obviously. Substitution, substitute for less hazardous material, reduce energy, for example, lower speed. That could make it safer. Force, amperage, pressure, temperature, and noise, reduce all of those. You might be able to. Engineering controls like ventilation systems, machine guarding, sound enclosures, circuit breakers, platforms and guard railing, interlocks, lift tables, conveyors, balancers, a lot of engineering controls out there. Now they're throwing in one, and some of them do this, called warnings. Signs, backup alarms, beepers, horns, labels. But most of the time in the hierarchy of controls, warnings are considered administrative controls, which are procedures. All right, administrative controls do what? Change the way people work. Safe job procedures, rotation of workers, safety equipment inspections, changing work schedules, training, hazard communication training, confined space entry. These are just examples. And number 6, they're calling they're called number 6, personal protective equipment. Again, safety glasses, hearing protection, face shields, safety harnesses, lanyards, gloves, respirators. So again, ANSI Z10 is very similar to the one we're using. ANSI Z10 and others add a control category between engineering and administrative controls called warnings, which is considered an administrative control in the others. So that change is purely superficial. All right, here's what we covered. We've covered at the very beginning, we established the context of what we're going to do. We did risk assessment, and the part of that is risk identification. And as we found out, that is the most important part, because if you don't identify the risk, you really can't do anything about it. And then we're going to analyze that risk and then evaluate it. And then the last we just talked about is how we're going to treat it. Next up is monitoring and reporting.